That was Seth Schluter and Benjamin Hastings with Already on the Way. You're on Rima 94.9. It is at 4:15 and it's Tuesday afternoon. That means Creation Ministries International. And this afternoon we have Dr. Michael Thompson on the line from Creation Ministries. How are you, Dr. Michael?
I'm good, thanks. How are you, Mick?
I'm awesome. And look, it's great to have you. Now, this week we're going to be throwing a question at you that actually came to us last week. We'll be talking about some of the impressive rocky landforms that we see and how they point to Noah's flood. Now, Michael, I actually received this question about a particular type of landform in geology called a mesa. I think that's how you say it. Is it a mesa?
Yeah, I was actually having a look at pronunciation just before. I think mesa. So maybe it depends where you're from.
Yes, okay. Well, look, regardless, mesa, can you explain to us what they actually are?
Yeah, so it's an interesting type of landform, or kind of rocky landform. What we're used to is, when we look at highly elevated rocks, we think, oh, they're mountains or hills. But it's actually a bit different. So most mountains are formed from either an active or extinct volcano in the past.
Yep.
That's where you got the lava comes out, solidifies, you get rock building up. Or you can get uplift, and it can be both of these. Uplift when tectonic plates smash into each other and they push the land up and fold the rocks, and lots of pressure and heat that folds them and crumples them like the way I like to think about it is like I remember in engineering we studied the crumple zone of a car, and so if a car crashes, it's very well designed so that the front of the car takes a lot of energy.
Yep.
And it gets all smashed up, but it folds when it gets compressed, and it's a bit like that with the land when the tectonic plates, smash into each other and that they fold the land like that.
Okay.
So that's how mountains all, normally, or most mountains are like that. But then you've got these other examples where they're actually a mesa is it's sort of a leftover from where there has been a lot of erosion. And so I guess you could almost think of a wedding cake with lots of layers.
Yep. And
someone's cut a bunch of layers, cut a bunch of slices out in a bit of an uneven fashion. And you might think, oh, it used to be a flat surface, but now it's sort of hilly looking because things have been taken away, not because things have been added or pushed up. So the mesas are they're flat-topped rock formations that have bits and pieces left over from an erosion event. And so mesas are fairly wide. The similar type of structure that's more narrow and tall as a butte. And then you've got a plateau or a tableland, which is just a really large expanse. It's like a supermassive mesa. That's essentially what they are.
Okay, because I looked at some of the pictures, and they did look a bit like a cut-off tree.
Yes. Well, particularly a butte, where the formation is, or the leftovers of what was eroded, is taller and sort of narrower, tall than it is wide.
Yep.
Then of course you're starting to get something that looks more like a tree. And one of the challenges in geology is actually scale. And so if you ever see a geologist take a photo of some rocks or a rock formation, you'll notice they'll do something funny. They'll put their keys up near the rocks, or they'll put their hat in the picture, or they'll get someone else to stand in the picture.
Yes. And
the reason why is if you take a look at a big rock structure and you don't have anything to give you an idea of the scale, it can be very difficult because the cracks in the rock can look like cracks in a rock at a very small, centimetres scale.
Yes.
Or meters, hundreds of meters scale. They all look the same. So you need something in the image for scale. So if you don't have something in the image for scale, then a butte, a sort of tall column with a flat top, and it'll look like it has sort of layers, almost like a palm tree, and it could look like a petrified wood tree.
Yeah.
So I can see why people could confuse that if there wasn't something to scale in the image.
Yeah, right. Yeah, I often wonder when I look at pictures of Mars, you sort of think, oh, is that like a little tiny picture of a landscape or is it a giant? What, you have no idea.
That's right. Yeah, the scale of some of the there's some actually big erosion features on Mars too, big canyons and things like that. And you look at the picture and it's so hard to work it because there's no trees, there's nothing we recognise to put scale to the image unless they actually put a little scale bar down the bottom of the image to tell us.
Yes, smart move. So are there any famous buttes or mesas or plateaus in Australia?
Yeah, there's quite a few. So I'm up in the Northern Territory and Western Australia in particular. So these are sort of similar to buttes, but probably worn down. The bungles, if people have been there.
Okay, yep.
They're a bit more worn down because they're sort of rounded on top. But in the Kimberley Ranges, you've got some flat top areas. And closer to home, though, in Sydney, on the East Coast, you've got the Blue Mountains.
Oh, yeah.
Where you've got relatively flat, tablelands is what they call it, like a plateau. It's just another word for a plateau.
Yep.
And then you've got all these erosional features with these steep cliff faces. And then you've got some areas, so people might know of the Three Sisters.
Uh-huh.
They're probably a word for them. They're probably not buttes because they're not flat on top. They've been rounded off and eroded a bit more.
Yep.
So they're probably closer to what we call a spire. Although it's a bit subjective what you actually name it, but they're examples of this. And there's actually from the lookout. I remember when I was a kid, when I checked Google Images, it reminded me of when I was a kid and I went to the Blue Mountains for,
Yep.
I think it was with my family or for a school excursion, and there was like it's isolated flat top mountain in the middle, roughly flat top, which is Mount Solitary, and
yes.
that's probably the closest to what we'd say is a mesa. But of course the mesas and plateaus and buttes that people are most familiar with in images are from where the Grand Canyon is, so the Colorado Plateau region.
Yep.
They've got the really flat ones and all the layers, and so that's probably the most familiar to people.
Yeah, and they all seem to have layers.
Yeah, well, quite often so you'll get the flat layer on top, and then often the layers will actually follow the same, orientation as you go down as well. So that's also just a common thing in geology. I mean, you do get, if you've had uplift, which means tectonic activity and plates folding, then your layers will be tilted. Yep. But what's really good evidence for these that they're not uplifted mountains or volcanoes. They don't have volcanic rocks in them, generally speaking. They might have some intrusions. And the layers are flat, which means they weren't uplifted. And so that's the evidence to say, okay, well, these were flat landforms that were eroded away. And so those high points all used to be covered in sediment, and those parts of the rocks were eroded away. That's sort of, those flat layers point to that. It's not an uplifted mountain, but the plateau and mesas and buttes, that's sort of the classification.
Yeah. Now, here's the actual question. Are the mesas in North America petrified huge trees?
Yes, I think, again, that comes to the scale issue. They're not petrified huge trees. There are some very interesting petrified trees in America. There's this, I think it's Yellowstone National Park, I believe. They've got if people search online petrified forest in the United States, they'll find it. There's these all these petrified tree trunks. Some of them are upright and in different layers and fallen over. So it might be mixing the two of those together, but the mesas are not the petrified trees. The other thing is that the geologists actually work out the difference, because if you find some petrified wood, you can actually look at with a microscope. Generally speaking, you'll actually see the tree rings, the cell structure. It preserves so much of what isn't part of normal trees.
Yep.
Whereas if you look at the rocks in the mesas, they won't have those features. It'll just be put together minerals, usually a sandstone of some sort.
Right. So when people say they've found like a tree sitting up through layers that are meant to be millions of years old, and all of a sudden there's this tree sticking up the middle of these layers, are they always petrified?
Yeah, so that's usually a case of petrified tree trunks, and they're actually there's a special name for those types of fossils. They call them polystrate fossils or polystrate trees. The idea is that it's a fossil that goes through many strata or many layers, and so that's an example of essentially when you've got petrification is just replacement of what used to be biological, the tree cells and things like that. It's just been replaced by minerals, and of course the secular geologists say that has happened over deep time.
Yep.
And we actually say there's a lot of evidence to show this too. It can happen very quickly.
Yes. Well, it's hard for it to go the other way. Look, we've got to go into a little break right now. Hey, if anybody has any questions for Dr. Michael, please send them through to our text line. The number there is 0401 949 949. There's SMS. Just text 0401 949 949. Now, coming up next, we'll have, let me see, it looks like a song by Point 5. This is called Thank God You're on Rima 94.9.
Year's Day.
That was Switchfoot with New Year's Day. You're on 94.9. It is 23 minutes to 5. And we have Dr. Michael Thompson on the line from Creation Ministries International. He's been talking to us about mesas and buttes and even petrified trees. Dr. Michael, tell us a little bit more about petrified trees. How's this petrified wood formed?
Yeah, so petrified trees and petrified wood is it's actually one of my favourite things in geology because it was the first fossil I actually found myself. And you can, if people have had a look around, you can get a fossicking license. Just go online and they're usually pretty cheap. And certain areas you can fossick, and I did some fossicking down at the Brisbane River in an area near there, and where I live, and found some petrified wood. And it's essentially it's rock now, but it used to be wood. And what's happened is that it's over time, it's the biological material has been replaced by minerals, usually silica-rich minerals, and it essentially turns into a quartz-like mineral or rock, and then it's rock solid. It's actually quite it's a very, as far as rocks go, petrified wood is actually one of the harder ones too on the hardness scale. So it's but yeah, you'll often see the wood grains in it, and even burrows of creatures, and all the evidence that this is definitely wood.
Yep.
And then of course you get the small chunks like the size of your fist, and if you're really lucky, you stumble across a tree trunk. There's places in the world where we get the whole trunk as well.
Yep.
Which is quite impressive.
Yeah, we sometimes see like those big tree trunks growing through layers of or even sandstone. And you sort of think, okay, I wonder how that happened. I mean, because we often get told by evolutionists, that sandstone layers take millions of years, and then all of a sudden there's this tree up through the middle. But how does the tree get those minerals from sand and silt?
Yeah, so the formation process is that, and this is actually agreed upon by both creationists and geologists. The thing we disagree on is how quickly. And essentially you'll have trees that are either rapidly buried by volcanic ash flow. So if you think about Mount Vesuvius and Pompeii, where tragic, in history, where people were buried and sort of encased, things like that with trees. Or you can have rapid burial with sediment-rich water, and you can start to think about how we think of Noah's flood with a lot of tectonic activity, volcanoes, lots of water with lots of sediment. It's starting to sound like the flood here.
Yeah.
That's what I think accounts for it. But the idea is once it's buried rapidly, then the sediment-rich water is really where it could be through the groundwater, or just through the burial process itself. But that brings in, even through the volcanic ash, it seeps through and it brings the mineral-rich water and starts replacing the actual biological material to then preserve the wood and the structure of the wood, and that's how it can look like wood. But the problem is that, of course, wood has a habit of rotting when buried. I don't know if I actually set up a veggie garden at my parents' house, one of those raised garden beds.
Yep.
And one little trick you can do is just throw a bunch of big sticks and wood in the bottom, so you don't have to buy as much soil. And of course, eventually you've got to top up your soil eventually, because it all sinks, because the trees and the wood breaks down and turns into compost pretty much.
Yep.
So you need that rapid burial to seal it and preserve it, and you need conditions to actually start to transition it as well. So with the global flood, you've got those rapid burial, it preserves it in super deep, high pressure layers, and the petrification could have happened quite quickly.
Right. So when you say that the high pressure, when one of these trunks is sticking through a layer like that, it then needs a bunch of layers on top for that pressure to happen, wouldn't it?
Yeah, yes, you need that. You got the layers as well, and actually the way that when they're upright, what's fascinating there is you've got often the root system is not preserved, and so sometimes the idea is, the tree was growing in place, and gradually over time, the sediment just kind of built up in layers, which fits the old millions of years model. It's consistent with their interpretation of layers. Yep. But the problem is you'd have a rotting tree by then, and it wouldn't work. So the way that there's actually at Mount St. Helens, when they had the volcanic eruption there, it actually knocked over a whole bunch of trees and sent all the trunks into the lake. And what they found is that over time, some of those trunks got waterlogged, and of course the violence of the volcano stripped them of their branches and roots, so it's just the trunks.
Yep. And
then eventually they tipped root ball down, or the root side, even though most of the roots are knocked off. Yes. And then they tipped upright, and then eventually sunk down into the sediments below. And so we think that during the flood, what probably would have happened is, as the flood waters were rising, sort of pulsing their way up and up and up, certain points as different layers are put down, that some of these log mats or these floating tree trunks being knocked over by the flood eventually get so waterlogged they go upright.
Yep.
And then they sink down into these sediment layers, which then get rapidly buried over as well. And then you've got the water with all the minerals in these thick layers starting the petrification process as well.
Yes.
So it actually fits quite well with the flood model. And then even the petrification process, there's actually really good evidence. Some Japanese scientists put some wood samples into a lake with a volcanic crater, and the mineral-rich springs of that lake have got this special type of acidic hot water, and within 7 years, the wood was almost entirely petrified.
Wow.
And so they reckon give it about 100 years and you'd have completely petrified wood. And so you've got these, again, hot, mineral-rich groundwater, which would have been happening during Noah's flood with all the tectonic activity and volcanoes.
Yep.
And just the ocean temperature would have been a bit warmer too. You can see how this petrification process, the evidence we have today of petrification, is it happens in tens of years, not millions of years.
Yep.
And so after the flood, these trees and things, they would have been petrifying for the next years and so, and probably within 100 years, they'd all be rock solid.
Yeah. Wow. Yeah, that's insane. So with all these like messes that we've been talking about and buttes and even, well, yeah, I guess the messes and buttes, that sort of thing, how are they all formed?
Yeah, so that we've got all these straight flat layers, and the idea is in the rising phase of the flood, when the floodwaters are rising, the first 150 odd days, from what we read in the Bible, that's when you've got these pulsing, rising floodwaters, and every time they pulse up, you deposit a new layer, and then it goes down a bit, but then it goes up even higher the next time, deposits another layer.
Right.
And so you get those straight layers depositing,
Yep.
and then the waters reach their height, and then they start to recede for the sort of the second half of the year, as we read in the Bible. And then as it recedes, then you've got all these flat layers stacked up, and then as it starts to recede, you carve off flat erosion surfaces, and then eventually, as it recedes further, it starts to carve out canyons and gorges, and so you think about the Grand Canyon, and I mean, I think it was most likely during the receding phase of the flood.
Yep.
And things like the Blue Mountains, all the runoff, the steep faces, and a lot of the areas in Australia face the ocean as well.
Yep.
Imagine that running off and carving these gorges out and draining off into the oceans where the water is today.
Yeah, it makes sense, doesn't it? Wow. And of course, the Bible talks about how the mountains got pushed up. So of course that's where the countries, the land is now, and then the oceans are where it sort of dropped down, and because the whole world was covered, would have looked a bit like a marble covered in water back then. But then as the mountains got pushed up, that water would have been roaring coming off the land.
That's right. So that extra elevation gives you a height difference, you have more potential energy, and then that water is going to really cut things out even quicker. You get faster flows. So that's right. That combination between the uplift in general of the lands and then that erosion from the water flowing off gets some spectacular erosion features.
Yes, absolutely. All right. Well, look, it's that time again. It's 12 minutes to 5. Dr. Michael Thompson, another awesome week, and thank you so much for telling us all about, well, buttes and mesas and petrified trees and how they're formed. That was really interesting. Thank you so much.
No worries, Mick.
And, of course, you're from creationministries.com, Creation Ministries International. You guys have a website called creation.com. And if anybody has any questions, go to creation.com. There's a little little box at the top you can type your questions into. Thousands of pages of information. And look, the other option, of course, is send us the questions. If you have any questions, send them through, and we can ask our creation speakers on Tuesday. They can answer those. Well, today was pretty much answering a question from last week. So thank you again, Dr. Michael Thompson. That was awesome. You are on 94.9 this afternoon. It is 11 minutes to 5, and we've got For King and Country up next, and Stephen Malcolm with Yes.